So let's do this. Let's first off, even if you've seen me do this and you've done it yourself, I think you could use another look at it. But also for the people that just got this thing, let's remember how to use this thing real quick. So say I had a normal curve. Yeah, it'd be awesome if you guys all just said, we have a normal curve. All right, so we have a normal curve. And I want to know the probability that z is less than negative 0.14. All right. So let me ask you a couple things about this. Whatever data value that represents, the negative 0.14, can you tell me anything about it? Negative 0.14. There's a few different things you could say. What does the z-score tell you? All of a sudden you guys are like, well, Jeff, it tells you. I like it, so you can just read it off. I love it. Right? So the number of standard deviations from the mean to the data. All right. So there's a worksheet that I created that I used with a pre-stats class that I think, if I would have remembered, I might have brought it in, but it's like too late to do this really. Has anybody ever heard of something called an astronomical unit?
Yep.
What is it? Who said?
I don't know.
Oh, you've heard it. Okay. You're like, dude, man. All you said was haven't heard it. All right. Astronomical unit is the distance from the sun to the earth. The average distance. You guys with me? Okay. It's like 93 million miles. Remember this call it. Now, to measure how far apart the planets are, do you want to write the miles? Why would it kind of suck to write the full miles out? The distance between the planets. Are they very small numbers? Are they very? There's a lot of frickin', I'd much rather say that maybe Venus is 5 astronomical units from Jupiter. And what would each astronomical unit be? 93 million miles, the distance from the sun to the earth. So I can choose a unit to use to measure things. And how big should that unit be? Probably kind of like the average distance of what you're measuring is. I really want this to make sense. So if I wanted to talk about the distance between people in this room, would I want to use millimeters? No, because I'm like, how far is she away from her? I'd probably want to use like feet. Because that's about the distance away that people are in the room. Do you guys get what I'm saying? If I'm talking about planets, do I want to use frickin' feet? Do I? Could I? Yes. Do I want to? No. Do you guys start to see what I'm saying? Now what has this got to do with statistics? It's got everything to do with statistics because z-scores measure distance. What unit do they use? Standard deviation. Why does that make sense? Because standard deviation is the average distance from the mean to a data point. That was on that last test, that question. Oh, shit. Do you get the feel for that? So how far is a planet away from the sun on average? Okay, that seems to be a good, let me use that as a unit. And then 2 units would be 2 Earth distances, right? So instead of writing down 147,538,622, I could say 3 or 2 Earth units or 2 AUs. Okay, there you go. So, a z-score tells you the number of standard deviations from the mean to that data point. Can anybody tell me the data point that is negative 0.14 z-score? Can you tell me anything about it? Why is it negative? Where would it be? Don't tell me the area. I don't want to know about the area yet. I just want to know about the negative 0.14 z-score. Whatever that data point is it above average or below average? Below. How do you know? Negative. Is it really close to the average or far away? I love you guys. You're all like, how the hell would I know, Jeff? I don't even know what they are. Well, it's 0.14. What's the average in the z-score? What would you put in the middle of a z-score chart? 0. Is 0.14 very far away from 0? No. Right? One step away, there's 68% of the data in there. So 0.14, that's not very far away from the mean at all. So I know it's below average, but not by much. So, no. Are you guys with me? Do you have to know everything what I'm saying right now to do this problem? No. If you know everything I'm saying, do these problems make more sense and are they easier? Yes. It's crazy. So, the mean does what to a normal curve? Cuts it in half. So if the question was probably z less than 0, you shouldn't have to look at shit. What's the probably z less than 0? What did we just say? The mean cuts it in half, so what percentage is below 0? 50%. So what percentage should be below negative 0.14? A little bit what compared to 50%? I love you guys. You're all like, all right, I know I'm crazy. I know I try to explain concepts. I know that's insane. So the mean cuts it in half, so it's 50%. So here, where's negative 0.14? Down here somewhere, right? So below this, what should there be more or less than 50%? Less. Coolness. I love some of you guys are like, obviously less, dude. And some of you guys are like, how the hell do you know? It's just, you can see it. There's less. There's a smaller tail, right? So what do you get when you look up negative 0.14 in the chart? Let's see. Let's remember how to use this chart. I want to go to the negative side. Yeah, negative 0.1. Negative 0.14. So these are the second decimal place. Negative 0.14. I like that number. 0.4443. You guys see that? Yes. Okay, I know we've done this several times, but it's still relatively new. And some of you guys maybe have never seen this shit before until just now, because you haven't watched those videos that I put up for you. All right. So this would be, get out of the way, 0.4443. Why does it make sense based on everything we were just talking about? That is a little bit less than 50%. So if I have a chart that's supposed to tell me the area below a z-score, what, like for something like negative 3, it should be a very small number. What happens as I get closer and closer to 0, the number should get bigger and bigger. So what happens here? At negative 3 something, it's really tiny, very small amount out there. As you get closer to 0, the area gets bigger. I keep getting more and more area below me. That's exactly what the chart shows me. And if we knew the formula for these areas, we would do it just like we did with uniform. Why was uniform distribution so easy? Because what kind of area does it make? A rectangle. What kind of area does that make? I don't know. Wavy rectangle, Jeff. Sure, why not? Rectangle left in the sun. Oh. Okay. I love you guys. It's too early for math and for you trying to make jokes, Jeff. All right, I understand. So, let's come back to this. So these first few were just like the one we just did. Whenever you use the chart, what's the only thing the chart understands? Areas that are where? Areas that are below the z-score. That's all it understands. That's why it's just one sheet. So if I want an area above, greater than something, I have to look that number up and then do 1 minus to get the other side. I like it. They could have made like volume 1, volume 2 of this and just tell me all those answers, or I could just do that instead and just have one sheet to carry around. Right? I don't care what you think. We decided on this for you. One sheet. Okay. So let's finish this up. The second problem. What's the main difference between the first and the second? The first starts with z-scores and the second one doesn't. And what's the only way I can use this chart? 2 things I want to hear. When am I allowed to use this chart? Normal distribution. And look, the chart tells you, holy shit, it gives it away. right? It's got a normal curve. You can only use it when it's got a normal, and also, what's the name of the chart? You can only use it when you have actually z-scores. Kick ass. So on the second problem, I don't give you z-scores. I give you times. So the very first thing we had to do in this problem was convert it to a z-score. And then I could look it up. So our z-score was negative 0.73 for this, and we could look it up and get the area. Okay. How are you guys feeling? Besides tired and wondering why you chose a 7 a.m. stats course. Okay. So let's finish this up. Let me get a clean sheet. Let's start right here. We finished this one. Let's start right here. What goes right in the middle of this picture? I love it. 33.64. Why does that go there? Because it's the mean. The mean goes in the middle. Where is 53? Up here. And where do I shade? Right. I want more than, so it's just going to be right there. So the answer should be relatively small percentage. It's definitely going to be less than 50%. I know that. So what must I do with this guy? Let me do it for this guy. This guy becomes 0. Okay, whew. Now it's your turn. Can you make this guy into a z-score? What's that z-score formula? Yep. Good. Why does it make sense? Because it is a distance from the mean to the data point in standard deviations. It's how many standard deviations fit between those two. Okay. So what do you guys get? Let's see. Can you take a second? Does anybody need a bar calculator? You're going to definitely need a calculator right now and later. So you know what to do. Oh, okay. So ask me here in a minute. Oh, really? Is that one? Is the one about the median? Because that's number 2.
It didn't have an X. Can I do the formula? Can you do the formula now?
So real quick, is it this one here?
Yeah.
Okay, real quick. So normal curve has a mean of 61 and a standard deviation of 15. What's the median? In a normal curve, where's the mean? In the middle. And what's median mean? The number that's in the middle. So for a normal curve, the median equals the mean equals the mode, because it's also the tallest point. So if the mean is 61, what's the median? 61. Yeah, so that was not a formula problem, it was an idea problem. I like it. All right, so you guys got this done yet? Let's see. I know the mean is 33.64. I know the standard deviation is 8.81. So those have to go here and here. And the data point I'm curious about is 53. So what do we get for that z-score? Oh, I got all the answers.
2.2.
2.2, I love it, 2.2. Now everybody take a minute, don't say anything out loud, look that up on the z-score chart. All right, guys, what are you getting for 2.2? 2.20, yeah, 9861. But do you see how to do it?
Yeah, I just did 2 and then I went over 2.
Oh, I see.
Instead.
Oh, you did 2.02. I got you. So 2.2, 9861. I like it. See, everybody see how to read that sucker? So where's 9861 go on the chart? It's, yeah, anytime, the minute you look up a z-score, you put what you get right there. This isn't because I said so. You don't have to do that. This is Jeff saying this is how to be nice to yourself. Statistics, you don't know it. It's hard enough already. Why be mean to yourself? So when you look up a z-score in the chart tells you the area below it. So immediately put the thing you just got below the z-score you looked up. So have we answered the question yet? As Jeff forgets what he just said. There it is, 9861. Did we answer the question yet? No. Because we were nice to ourselves and we shaded in where the answer is. Have we gotten this side yet? No. So what would that side be? I like it. And that's the step that I've been getting you ready for forever. If I know one chunk, it's 1 minus that to get the other chunk. And it's the other chunk that the question wants. All right. All right, so do this one. I think, how far did we get on that one last time? We got a little bit of the ways. So let me kind of recapture where we got to. Let me put that over there. Wah! So I need to convert both of those numbers into z-scores. I pointed out last time that this problem is exactly the same as that problem was. They just aren't z-scores yet. So go ahead and try to convert both of those into z's. Just to remind you guys, this so sucks when this happens, but when you put it in the calculator, you got to tell the poor little calculator what the top is. It ain't got no eyeballs, just to show off my grammatical skills. Thank God it doesn't. That would be freaky. Has anybody got the z-score of this first one for 15.5?
Negative 2.059.
So negative 2.06. So why do we make z-scores to go to 2 places? Because the chart only goes to 2 places. That's a gimme. Everything else we do, you can take it 4 places and be covered, right? Standard deviation has to be at least 3. Probabilities have to be 4 places. So if you just make everything 4 places and z-scores 2, how do you remember that? Because the freaking chart only goes to 2 places. So it's reminding you. So what about this one? Anybody got this one yet? I like it. So if you have any trouble getting those, you need to show me what you did. I can help you. Okay, I like it. So now the same way we did this one last time, where we looked up both z-scores, we got the areas, and then we subtracted. to get the area in between, which makes an incredible amount of physical sense. Do the same thing here, right? If I look up negative 2.06, I get that area. If I look up negative 0.47, I get that area. And I want the area between, so I'm going to subtract those two. So what are these areas? What's this bigger area? Who's got that besides me? 3192? Is everybody able to find that? You guys agree with that? 0.3192? You guys are all right? Yes. All right, let's take a look. I like it. Dissension. So you're cool with negative 0.47, right? For the z-score.
I got negative 0.6.
Oh, okay.
Well, I guess I didn't round.
Huh?
Oh, I didn't round it.
There you go. Sweet. Okay, so negative 0.47. That should give you 0.3192. What about the other guy? The little tiny tail here? 0197? Okay. Yes.
I'm confused how you're calculating. Like, what did you do?
All right. You're cool with these z-scores, right?
Yeah.
Okay. Look up negative 2.06.
Oh.
Yeah. 2.06. Poor little thing is so. There you go, buddy. 2.06. There's the 0.0197. So watch this. I always. So how does what we're about to do today, after we're finished with this and after we finish with the other handout I've got, is we're going to start to tweak this process a little bit. So what process am I talking about? How did we do any of these problems so far in number 2? What was the very first thing we had to do after we drew the picture? We had to take that number and make it into a z-score, right? So a normal z-score problem starts with x. X could be minutes to find a parking spot. It could be length of the tail of a Tyrannosaurus Rex. It could be whatever, right? Everybody with me? X's are just raw scores. They're whatever I looked at and wrote down. They're the data. What do I do with those data points? I make them into a z-score. And then what do I do with the z-scores I get? What was the next step after we got the z-score? Area. Huh? What do we do after that? How do we get this? I think you're saying area. We looked at the z-score chart to get the percentage, the area. So this is a formula. This is a chart. Goes x, raw score, make it a z-score, a number of steps, because if I know how many standard deviations away, I know exactly how much area there is, how much percentage there is. What's the only time I'm allowed to do this step here is if I got a normal curve. Okay. So if I had any problem, any normal curve problem, I don't give a shit. The mean could be 3 billion. And the standard deviation could be 157 million. If I make a z-score and it's negative 0.73, there's going to be this much area. So taking the raw data, turning them into a z-score, tells me where that point is on the picture. Once I know where it is, I know exactly how much area is below it. So when I change this x's to z's, I'm standardizing them. And then I can use this one sheet that works for every normal curve in existence. That's why it's so important in statistics. Do I have a normal curve? If the answer is yes, I'm like, yeah, sweet, because I can use a whole frickin' chart of answers. I got all these answers, just wait for me to look them up. If the answer is no, shit. I have to use stats 2 stuff, which we don't even teach here. Damn. So if you never take stats 2, you'll never know. And some of you guys are like, I'm fine with that. Okay. Did I just give away too much? Yes. All right. So coming back to this. I want to know what percentage is between these, which is the same as what percentage is between these z-scores. So how do I get the area between those two? What do I do with these numbers? Subtract them. And again, that's the part that makes complete physical sense. And I love some of you guys are like, do you know what the word complete means, Jeff? Hopefully you guys get that. What do you get when you subtract those? 2995. So if this is true, then almost 30% of students look for a parking spot between that much time per week. Do it again, sorry. There's no keep it negative. It could never be negative because what does that number represent? Everything. There's 3 things you could tell me that this number represents. It represents an area. Can area be negative?
No.
If the area of your living room was negative 80 square feet, I don't want to step in there. I get sucked into who knows what, right? You guys sort of with me? What else can I say this is? It's a probability. Can probability be negative? No. This is also a percentage of things. Can percentage of things be negative? No. Okay, I like it. Sorry, Rune, I didn't make I'm coming down on you, but this is a good thing. People will sometimes subtract in the wrong order and just circle a negative number. That makes no physical sense. So it's got to be big minus small. Is that cool? Okay, I like it. Can z-scores be negative?
Yes.
Yes, because they are distance from the mean, and so negative just means it's below the mean. These can't be negative because they represent areas, probabilities. Okay. Do you guys remember how we did this one? If you don't, here's how we did that one. P58 is the 58th percentile. So this problem was what we just did with the z-score chart backwards. I normally know the z-score and I look it up to get the area. On this problem, I knew the area was 0.58, and when we looked that up, bam, that was the closest I can get to 0.58, and if I look out, the z-score is 0.20. So really, another way to think of that question is how far above the mean do I go so I have 58% below me? Well, the mean has 50%. If I go 0.2 steps up, now I've got 58% below me. Please let that make sense. So again, wow, the mean is 50. Where's the z-score got to be so I have 58% below it? A little bit up here. Exactly where? 0.2. So the mean cuts it in half. If I go 0.2 steps up from the mean, now I've got 58% below me. So if your height had a z-score of 0.2, that means that you are taller than 58% of people. Okay, all right. So another way to look at this chart is this is a percentile chart. The z-score 1.04 is about in the 85th percentile because 85% is below it. So if your test grade had a z-score of 1.04, you scored higher than 85% of the people that took the test if it's normally distributed. All right, Jeff. So what's the point of all that shit? Well, now this one is saying 14th percentile. Where would that be on the picture? Yeah, it's got to be down here somewhere because it's only supposed to have 0.14 in it. Can you find that on the chart? Don't say anything out loud. Does that look like a z-score? Yes, it does, right? 0.14 looks like a z-score. Is it a z-score? No, it's an area, it's a percentage. So where are you going to find it? In the body. And you got to look out. I don't know what the z-score is yet. So you're not going to find exactly 0.14. You're going to find something really close to it. What is it? What do you guys find? 0.14. Anybody found it yet? 1401. So obviously it's going to be, is it going to be positive or negative? The z-score. Huh? Negative, because it's below the mean. And then if I look at 0.14, 0.14, 0.15, 0.1401. So what z-score is that? Negative 1.08. I love it. I'm catching up to you. I love it. You're like, I said 8, dude. All right. So negative 1.08. That's not the answer, though. That's weird. Because the question says find the time. If it took somebody negative 1 minute, that means they got a parking spot before they got there. That's neat. Is that a time yet? No, that's a z-score. Okay, so we got this thing, which I might want to film. Sure. Let's film that bad boy. There you go, buddy. All right. I have no idea if this is going to help you, but this is a classic z-score problem. They give me like the years that a dog is going to live. I can get the average and so forth, and I want to know the probability my dog lives longer than 11 years or whatever. So I can convert 11 into a z-score, and then if I know it's normal, I can look it up on the chart and get the probability. So that's a classic z-score problem. Now, this one is this backwards. What was the first thing we knew? Percentage. What did we just do? Converted it back to a z-score. I like it. And then what I have to do next, convert it back to x. Now, real quick, this formula is good. It's solved for what letter? It's solved